Welcome to Precalculus Concept 27b, graphs of sine and cosine. We're going to talk about the amplitude and the period for y equals sine x. There's 4 boxes. So in the last video, we had a basic understanding of where the heck even y equals sine x comes from. Now we're going to start to take apart the nitty-gritty within that graph itself. And the very first thing we're going to the very first idea is this idea of amplitude. And the amplitude of a graph is defined as the distance from the midline to the highest or the lowest point. So take a look at these two graphs that you see before you. One of the graphs is red and one of the graphs is blue. The red graph is the graph of y equals sine x. And remember, we have our 5 basic dots. We have 0, 0, we have pi over 2, 1, we have pi, 0, we have 3 pi over 2, negative 1, and then we have 2 pi. So that's just one basic cycle. I kind of gave you more of a larger view just for the sake of this box. The amplitude then is the distance that is measured from the midline, and the midline is the line that goes straight through the center of the graph that cuts in half, to the highest point or to the lowest point, and that is a value of 1, just like it is in the range. So in this case, the amplitude is equal to 1. Because it's the distance from the midline to the highest or the lowest point. But take a look at that blue graph. The equation of the blue graph is y equals 3 times the sine of x. So the 3 is being multiplied by the sine x function. And you'll notice that what it does is that it increases the amplitude from 1 all the way up to 3. So the midline now gets increased from, instead of a value of 1 unit, it's now a value of 3. So in general, when we are dealing with the equation y equals a sine of x, we say the amplitude is equal to the absolute value of whatever that a is. The amplitude is the absolute value of whatever that a value happens to be. So here's a quick little guess for you. In this problem here, y equals 7 sine of x, can you guess the amplitude? Yes, hopefully all of you guessed the amplitude is equal to a value of 7, because the absolute value of 7, of course, is 7. And for a visual, the distance from the midline to the top is worth 7 units, or the distance from the midline to the bottom, or the lowest point on the graph, is also worth 7 units. So we have an amplitude of 7. Okay, box number 2 is all about the next concept, which is going to be period. And the period is defined as the distance, which is usually in radians, to complete one full cycle. And again, I have 2 graphs for you. I have the very basic graph in red, which is the sine graph, sine of x, and then I have a graph in blue, which is the sine of 2x. So notice that where the 2 is. Let's consider the basic one first. Okay, my 5 points would be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi 0. And right now, the distance in radians to complete one cycle is 2 pi. So the period is equal to 2 pi in this particular case. However, it's different for the blue graph, right? The blue graph looks different. So if I change over to blue and I do my 5 dots, I'd have 1 dot here, I'd have a dot here, I'd have a dot here, I'd have a dot here, and then I would have a dot here. Now that's one full cycle. Now you'll notice that it only took a distance of pi to complete one full cycle. So the question is, how do I come up with that period? So the period is equal to pi. So the way that we do it is we take the number that's in between the function and the variable, and we take our original period, which is 2 pi, and we divide it by whatever number is in there, and that cancels out to give us a value of pi. Okay, so again, we take the original period of the sine function, which happens to be 2 pi, and you divide by whatever number is in between the sine and the variable. So in this case, what does the 2 represent? The 2 represents that you get 2 full cycles of a sine curve on a distance of 2 pi. That's what the 2 represents. So I just highlighted those for you. There's the first one, and then there's the second one. So you get 2 full periods, or 2 full cycles of pi, of sine on a distance of 2 pi radians. So therefore, one period has to be pi. Okay, here's what I want you to do. I want you to take this information, and I want you to guess what the period would be for y equals the sine of 4x. Okay, hopefully you got the answer of pi over 2 as your guess. The red curve, of course, is your original sine function. So 1, 2, 3, 4, and 5. And notice you have a distance, a period of 2 pi. So what we want to do is we want to take that 2 pi and divide it by whatever number is between the trig function and the variable. So I took 2 pi divided by 4, and I got pi over 2. So what does that mean? That means that in a distance of pi over 2, which would be this distance right here, pi over 2 radians, I have gone one full complete cycle of sine. So here it is. Here's my midpoint, my high point, my midpoint, my low point, and then my midpoint. So right there, this is one miniature cycle of the sine curve, and it happens to take place on a distance of pi over 2. Again, the 4 means that there are 4 of those cycles in 2 pi. So there's the first one, there's the second one, there's the third one, and then there's the fourth one. So that's what the number 4 represents in this particular problem. But the period is pi over 2. Okay, box 3 is another example. We're going to determine the amplitude and the period for the function y equals -3 sine of 6x, only from 0 to 2 pi. Okay, let's start by reviewing the amplitude. Okay, the amplitude is equal to the absolute value of -3, which happens to be right here. So that means I'm going to have a value of 3. By the way, that negative sign out in front means I'm going to have a reflection over the x-axis, just like it does in every other graph that we've studied so far. But to answer the question, the amplitude would be a value of 3. Then the period. The period is equal to, I look here. I look at the number between the trig function and the variable. I take 2 pi and I divide it by that number, divided by 6, so I would get a value of pi over 3. So the amplitude would be 3 and the period would be a value of pi over 3. Okay, last box, let's do an example together. We're going to sketch y equals -1/2 sine x and then compare it to y equals sine of x. Well, to note, I should realize that the number that's sitting out in front represents my amplitude. So therefore, the amplitude is going to be the absolute value of -1/2, which in this case is just a half. The negative is going to give me a reflection over the graph, over the x-axis, rather. So therefore, to make a quick sketch and compare the two, I would start by making my basic regular graph sketch. I'd have 0, and then pi over 2, and then pi, and then 3 pi over 2, and then finally 2 pi. And this is going to go up to 1 and then down to -1. So for the graph of y equals sine of x, here are my 5 basic points: 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and then 2 pi. So here is the graph for sine of x. And now the graph of -1/2 sine x, I'm going to have a reflection. So this point stays there, this one goes to here, this one goes to here, this one reflects to there, and that one goes there. So I have a reflection of the graph. Remember, anytime there's a negative out in front, it's going to reflect over the x-axis. So my green graph would be y equals the negative sine of x. And then finally, I'm going to make the amplitude 1/2. So that means the distance from the midline to the lowest point was only going to be half. So there, 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 and there. So the final graph would only be sort of half as tall as the green graph there. So y equals -1/2 sine of x.